With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. So the given question here is a circular insulated copper wire loop is twisted to form two loops of A and 2A as shown in the given figure. At the point of crossing, the wires remain electrically insulated. So at this point, the wires are insulated from each other. The entire loop lies in the plane of the paper. The uniform magnetic field B into the plane of paper. At time t is equals to 0, the loop starts at rotation about a common diameter as the axis with a constant velocity omega. And the magnetic field, which of the following options are correct? So there was a loop which was bent over two loops to make an area of A and then 2A. And for that, we have magnetic field, which is uniform magnetic field into the plane of the paper. And this is rotated with a common angular velocity omega. For the given question, we have four options. The option 1 stated as the net EMF induced due to both the loops is proportional to cos omega t. The rate of the change of the flux is maximum when the plane of the loops are perpendicular to the plane of the paper. The amplitude of the maximum net EMF induced due to both the loops is equal to the amplitude of the maximum EMF induced in the smaller loop alone. And the last option, the EMF induced in the loop is proportional to the sum of the areas of the two loops. Okay, so let us start solving. We know that for first loop, the flux is equals to AB as the area is A. For second loop, we have flux is equals to twice of AB. And also in general, we know that phi 1 is equals to AB cos omega t, because flux is equals to B dot A, which is equals to BA cos theta, and theta can be written as omega t. So in general form, flux 1 is equals to AB cos omega t, and flux 2 can be written as twice of AB cos omega t. Therefore, the EMF of 1 is equals to minus d phi by 1 by dt is equals to AB omega sin omega t, just the differentiation, making it option number 1. Similarly, the EMF 2 will be twice AB omega sin omega t are second. Now the EMF induced in the loops have opposite polarization because of the orientation of the wire. If the current is flowing, let us suppose that the current is flowing towards this direction at a particular time, then it will be moving in this direction. It will go through all the way like this, then this, to complete the loop. So as you see, the current flows in this direction, but the current flows in this direction in the upper loop. And therefore, the difference we have here, so the difference being that the current are in opposite sense. So voltage or the EMF are also in opposite sense. Therefore, the net EMF E net will be E1 minus E2 taken in mod. So it will be AB omega sin omega t. So from here, let us check the options for once. We will get option number 1 correct because the EMF is directly proportional to cos omega t. Now, the rate of change of flux, we all know the rate of change of flux is equals to EMF induced. Rate of change of flux d phi by dt is proportional to sine of omega of t. Remember that the net EMF induced in both loop is proportional to cos omega t. So cos omega t, and we have got sine omega t. So I'm sorry, this option is not correct. But option 3 is correct. The amplitude of the maximum EMF induced in both the loops is equals to the amplitude of the maximum EMF induced in the smaller loop alone. This option is correct. Now moving towards the solution, we know that the rate of change of flux is equals to the EMF induced proportional to sine omega t in equations 1 and equation 2. Therefore, the EMF induced in the loop is equals to AB omega sine of omega t, which is proportional to sum of proportional. We have EMF proportional to sum of areas. Now we have to infer something from here. What do we infer? We infer that the rate of change of the flux is maximum when is maximum, which implies that the EMF is maximum. Rate of change of flux, that is d phi by dt, is equals to max. Then EMF is also equals to max. This is the case because nothing is changing out of the areas, the current, the magnetic field, nothing is changing. Just the areas are changing. So it is directly proportional to the sum of the areas because flux stands for BA, and since B is not changing, the only factor remaining, the areas are changing. So we get to know that when d phi by dt is equals to maximum, the EMF is equals to maximum. Therefore, AB omega sine omega t is maximum at 1/4 and 3/4 of revolution. Is max at 1/4 and 3/4 of revolution. Let us check how. When they are perpendicular to each other, let us suppose that this is the magnetic field, and when the loop stands like this, in loop stands towards facing towards the right side, no flux lines have been cut. So as soon as the loop moves in any of the directions, clockwise or anti-clockwise, the loops start cutting the magnetic field again. So in this case, the flux increases suddenly and we will have a peak at 1/4 and 3/4 of the revolution, because loops are perpendicular. Now let us check back at the options. We have the rate of the change of the flux is maximum when the plane of the loop is perpendicular to the plane of paper. We just check this. The EMF induced in the loop is proportional to the sum of the squares of the sum of the areas of the two loops. The EMF induced in the loop is proportional. Did we write that somewhere? Proportional to the sum of areas. Did we write it somewhere? Yes, we did write it here, proportional to the sum of the areas. But actually this is not the sum of the areas. I wrote it wrong here. This would be difference of areas. Let me explain how. When we calculated the net EMF, we subtracted the EMF1 minus EMF2 because they were in opposite sense. So actually we were not subtracting anything. It is just the difference between the areas. Here we had A and here we had 2A. So the basic difference is not the sum, but the difference in it itself. So this option is incorrect. This option is incorrect. So at final, we are left with two options. Option 2 is correct and option 3 is correct. Hope you understood the solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.